All right, welcome back, everybody. Hope you had good lunch, and we are all raring to go. And Silvano is online, tech check, everything done, and he is all set. So Silvano Coriani is working with Microsoft, and we are truly honored to have him. Another 25 years of experience with databases, and not only SQL. If you read his profile there, it is SQL Server from 6.0 onward. So we had Bob, we had Buck, and now we have Silvano with such great experience, and not only SQL, as I said, Oracle, IBM DB2, Postgres, and whatnot. Silvano, this is truly amazing. And he is bringing a session which is design your backend APIs with Azure SQL Database and GraphQL. So this is something really new that we will all learn today. Silvano, thanks for joining us. Thanks for taking out time out of your busy schedule. Over to you, Silvano.
Yeah, thanks a lot. Thanks a lot, Amit. And thanks for this great initiative. It's very. I'm very grateful to be able to present in front of a number of friends from the SQL community here, especially in those tough times of lockdown and such. It's a great opportunity to get connected with the community, as I was saying, and I'm very glad to be here, part of this.
Excellent, excellent. Truly honored.
So, as you said, I actually celebrated this week my 30 years of my 30 years anniversary working in the industry, and it's been a great journey. I started, have my roots in industrial automation. I was working as a low-level developer. And then I moved up to distributed systems and databases. But I always feel like I'm a developer by heart, and this is matching very well with what I'm doing right now in the Azure SQL DB team. So I'm glad to be able to talk about this and to provide also the developers angle as part of this great conference that we are doing here.
No, absolutely. In fact, we had like so many sessions spread across DBA, and it's good to have a few developer sessions. So I'm sure the audience is really looking forward to your session. And just to let you know, we have kind of close to 400 people live now from about 41 countries. So you're all set.
Fantastic. So can I share my screen?
Of course, please go ahead.
Okay. Hope is all set.
Yes, we can see it.
Perfect. Okay, so let me first introduce myself. Again, my name is Silvano Coriani. Right now, I'm a principal program manager in the Azure SQL Database team, and my goal is to kind of entertain you for the next hour or such, talking about this technology called GraphQL that has got a lot of traction recently after being introduced a few years ago from Facebook, actually. And so let's see what the agenda. If I can move my slides, here we are. So the agenda for today is to go through the so-called 5 W's of GraphQL. So a brief introduction of what the technology is about and where it, why it's been designed this way, and how this can be interesting for backend developers that wants to interact with what all sorts of relational stores. Specifically, in this case, we are talking about Azure SQL Database, and how to consume a GraphQL services from your applications. And we are going through this with a lot of interactive demos, right? So let's start with a very kind of short introduction here. So GraphQL is a set of specifications defined by Facebook that has introduced this new technology for basically being able to design more interactive applications. You probably remember some of the first mobile applications that Facebook has introduced in the market. Those were not so great, and one of the reasons is that there was a lot of interaction between the mobile device and the backend APIs that originally were designed with the REST principles in mind, and you know, they come out with a better idea of basically creating a way to kind of being able to query APIs with a declarative language, right? And be able to basically integrate both other API calls and access to data sources like Azure SQL Database or other data stores with the same language, which is basically giving us the ability to describe what are the data entities that our application needs to interact with, as I said, with a declarative language here, strongly typed, where you're going to define your types, and you know, the ability to actually query for exactly what you want. In terms of shape and form of the data that we are retrieving, and basically get predictable results. So a great source of learning for this technology is actually the GraphQL.org site. I'm just going to quickly show you how it is, because I think it's very important. Is basically providing you all the learning opportunities in a very kind of well-guided fashion about you know, what is GraphQL and all the different characteristics and specifications for this query language, but also is providing all access to all the different existing libraries for all existing programming languages and framework. As you can see here, you know, the list is pretty long, and is very comprehensive. So I've been using this as a great kind of learning resource for learning this particular technology. So I definitely point to you at that as a learning exercise. But why you know, Facebook did introduce this? Essentially, it's you know, it's a way to be able to for client applications and for other services to be able to consume data services and ask and return exactly, you know, the data that we are looking for, where the consumer side, so the application side, is in command, is in a guided or guarded command. So because whoever is designing the backend, you know, GraphQL endpoint can define what data are available and what is the kind of you know, query formats that are available. But still, you know, there's a lot of empowerment here from an application, from a consumer perspective, on declare the kind of data that you need and potentially compose multiple streams of data coming from different sources in our backend, right? So the main goal here is to be able to, first of all, reduce the number of round trips that application has with service endpoints, and also potentially reduce the number of round trips between your application tier and your backend tier by basically running intelligent and composable queries that can basically retrieve the data you need from your backend service, from your database, and basically transform in a shape that is consumable from an application perspective. It's interesting because it's also self-describing and self-documenting. As we will see, the moment you are defining your schema and your model from a client perspective, you can discover whatever you know, data structure and whatever query is available on that particular endpoint, and you can start consuming through simple basically HTTP queries in this particular case, but it's really independent from the transport protocol, but typically HTTP is the most used one, and to be able to do some meaningful operations in your backend, right? It's also very interesting because you may be familiar with the REST approach for designing APIs. Most of these APIs are actually versioned, so you will end up with a lot of V1, V2, V3 type of REST APIs, while in GraphQL, you have basically a simplified approach of versioning your APIs. So your existing queries can be maintained, and you may want to over time deprecate certain fields, certain portions of your queries, but you don't need necessarily to apply the same versioning rules that you have with REST APIs, the way you are retrieving data, right? So basically, GraphQL is trying to solve what is usually referred to as the underfetching or overfetching of data in the backend. So the need of executing more and more queries to retrieve the amount of data that you need, or on the other side, to the need for retrieving much more data that you actually need in your application to be able to process the information you need on the consumer side. So I think in my opinion, and this is again an open area where we have a number of technologies like REST, like GraphQL. OData is also a technology that Microsoft and other partners like SAP have been promoting over time. So where exactly GraphQL is positioning? My personal opinion is that GraphQL is great for creating those kind of interactive front ends of your backend services, where backend services can be other API endpoints that you may have, or data sources like relational databases, NoSQL databases, and so on. And the familiarity that GraphQL can provide to mobile apps developers and single page application developers on web front ends is really a step forward compared to the traditional way you are consuming, for example, REST APIs. And it's also great when you are, again, creating endpoints where you are aggregating potentially multiple data sources, multiple data services, and existing APIs in a composable way, and you can create some business logic in front of that on the way basically your consumers, your applications needs to access these different data sources, right? At the same time, it's not for every single data service scenario or use case. If you have for example, to consume or to bulk load, for example, large result sets to your backend APIs, this is probably not the right technology, although you can implement some batching technologies, some batching approach here in order to, for example, pass multiple entities to your GraphQL endpoints and then get those entities stored using, for example, well-known kind of bulk load APIs in SQL and Azure SQL Database or other database technologies. This is probably not the right technology area or use case, right? If I have a highly, high throughput type of transactional scenario, and I have to let my backend services interact with another service, this is again probably not the right place for your GraphQL APIs, right? There are some areas like exception handling, which are a little different than compared to what you are doing with more traditional kind of API layers, right? And if you, for example, if you have to create a lot of those kind of maintenance, data maintenance screens, like CRUD operations, create, read, update, delete single entities within your database with zero business logic behind, this is where, for example, OData may be a better fit, given the capabilities of kind of filtering and dealing with individual entities. OData is exactly designed for that and can still be a good choice for that particular set of use cases. And there's a great article here published by Jeff Handley last year, or a couple of years ago, which is comparing GraphQL with OData, comparing and contrasting where it makes sense to use what. And I definitely point you to that article for more information around this particular comparison. So who is using GraphQL today? A lot of different customers and different sizes, from from small startups to large corporations. A number of these customers are using GraphQL as a way for their mobile or web applications to interact with their backend services. You can see some of the largest companies in the web space here, like Twitter or the same Facebook, PayPal, Audi, or some other manufacturers here. Travel, airline companies and so on. So it's, as I said, over the last 4 or 5 years, this is getting a lot of traction. So that's the reason why I thought it was good to start, talking about GraphQL in the context of our Azure platform and Azure SQL Database specifically. So this is also May the 4th week. So I thought, what better topic can be for showing up a little demo that is starting to kind of explore and familiarize with GraphQL, right? So there are a couple of great public resources out there about Star Wars movies and characters and so on. And there are two that are great here to compare and contrast with traditional technologies like REST on designing your APIs, and we can go through the two different approaches here and compare them, right? So this is again a public website which is giving you REST API support for querying your Star Wars entities, right? So there are a number of data entities here captured, planets, films, of course, and vehicles and species. And the classic approach that the developers of this site took to essentially design their APIs is what every developer would do, right? So they model their entities and provide access to these different entities so that you can, for example, query the entire set of, the entire data set of, for example, people here, or you can filter, like in this particular example, to the first entity in that particular ordered set, right? So if I'm requesting here this entity, I'm getting a result where, of course, number one is Luke Skywalker here. It is described with a number of attributes, height, mass, hair color, blah, blah, blah. And then, of course, there's a first association with the films of the Star Wars saga where Luke Skywalker is basically appearing, right? And so if you want to, for example, do a classic master detail type of drill down here, what you have to do is essentially start querying all these other entities here, right? So if I am a client application and I want to collect, all the associated information, I need to start executing multiple multiple queries, right? And so I can now I'm actually querying the wrong one, but again, you basically have to start querying again and again, and this means a number of round trips between your client and your server, right? Or you have to design specifically your aggregated APIs for that, which is a lot of work in the backend, right? So let's see what a different approach with GraphQL can actually be, querying the same exact data set, right? This is again another public website which is showing up this particular kind of a playground where I can play with GraphQL queries, and this is the way you are declaring your queries in GraphQL language, right? Where you have this first keyword query, you can also give it a name and create a named query here, but in this particular case we are querying this person entity here, and we are filtering for a person with the name Luke Skywalker, right? And then we are basically asking our GraphQL endpoint to provide a number of attributes here, right? And also we have attributes that are basically collections of or that are associations with other with other entities, like in this case, homework. And for this homework entity, we are asking the name attribute. Same for the films collection, and same for the spices and vehicles and so on. So as you can see here, what we are doing, we are composing up a query, which is, we are basically describing what we are asking to our endpoint. And when we are executing this, what is coming back is a single kind of entity, which is called data, which is the result of our query. And again, data is containing, as you can see, this is a JSON fragment, right? The query itself is not pure JSON, but what we are getting back is effectively a JSON fragment with a person entity, which is containing, as you can see, all the different attributes and collections. So, for example, in this case, for the films where the Luke Skywalker character is appearing, we see an array of JSON objects here describing all the different movies. And as I was saying, once we create this endpoint, we kind of inherit from the GraphQL framework all the different basically specifications that our particular query is exposing, right? So we can see here all the queries that we have available for all the different entities, and another important concept, mutations. So mutations are effectively our CUD operations, so our create, update, delete type of operations that are exposed by our GraphQL endpoint. Right, so you see the difference here. You can already perceive the difference between these two, right? And a number of other great GraphQL resources are out there. For example, GitHub is exposing through a GraphQL endpoint all his very large Among Us data set. So you can actually take a look at this playground here and start interacting with your own GitHub account here, and again you see as a kind of a self-documented in a self-documented fashion, you can see all the type of different type of entities that you have available, and you can start playing with it and for example query your own data or the public data set in the entire GitHub repositories. So again, those are interesting tools for you to start familiarizing with GraphQL as a query technology for data services. But how do we kind of design and implement a typical kind of GraphQL service? So in the diagram here that I have, you can see, for example, your in this case, your mobile or desktop apps or web apps interacting with your main kind of GraphQL endpoint here. And the GraphQL point will expose, as I said, a number of operations. So those are going to be typically queries where I'm retrieving data from the client app, or mutations where from a client app, I'm asking my GraphQL endpoint to execute something. Right, so data modification tasks or operations, right? Another important entity in the GraphQL technology is called subscriptions, where clients can actually ask, basically subscribe to an event on the server side and get notified when something is changing, for example, in that particular data entity and so on. So, right, so it's a kind of a full async path that we also have available from a GraphQL perspective to design our applications. So applications are going to send this query request. So query requests can be sent over whatever transport protocol, but typically in a HTTP scenario or a mobile app scenario, this fragment here will come as a post body in a HTTP request, right? So it's going to be as simple as having whatever HTTP client available on your device and just posting a HTTP request. And on the other end, on our GraphQL service, what we are going to have is a set of what are called resolvers. So resolvers are effectively the way in which GraphQL is interpreting my query request or my mutation and is doing something. That something can be, for example, access to our backend database or multiple databases, or can be interpreted as a request for another service. And this service can be whatever service is accessible from our application. It could be another GraphQL service where we are filtering out from other data sources and aggregating in a single response. But this can also be, for example, another REST service, or one or more databases where we are again trying to reduce the number of round trips that application clients are executing here. Right, so this is effectively the goal, the main goal of GraphQL as a technology, and also giving the ability for consumers, for client applications here to not being constrained by exact number of query to a request to a well-defined REST APIs, but effectively to be able to interact with whatever entity has been described here in the GraphQL schema, as we will see in a second. Right. So this is the kind of landscape where we are going to adopt GraphQL as an API technology in our backend databases. So the concepts, the important concepts that you have to start thinking about for GraphQL are this ones described here in the slide. So first of all, the schema. Schema definition is the most important concept here, where you're basically describing the entities that your applications or your consumers are going to interact with. Right? So there is a specific schema language, which is similar, if you will, to what in your programming environments you are using for other technologies. If you are old enough to remember, for example, schema definition languages or IDLs or stuff like that, this is very, very similar, where you're basically describing the interfaces you are dealing with, right? And then queries, you're basically declaring how those entities can be retrieved from an application. And this is basically the R in the CRUD type of operations that you're typically doing when you are interacting with a data store, right? Mutations are those data modification tasks or operations that you want to expose to application, like create a new user, create a new purchase order, create or delete or update one of those entities. And those entities, remember, can be composed. So I can have a single data modification operation that is accepting, for example, multiple entities or entity types. Like, for example, I can create a new customer, a new order, and a number of order lines within the single round trip between the client and the server. And then it's up to our resolvers, which is the other important concept here for GraphQL, on how to take the information that have been transferred from the consumer, from the client application, to the mutation operation itself into something which is interacting with other services. In this case, for example, can be our Azure SQL Database instance, or can be another service in the backend. Right? There are a number of also advanced concepts as part of GraphQL that you can see here. For example, data loaders. As the name implies, data loaders are are entities that are capable of, for example, from a backend service, preload a bunch of data entities and possibly also caching at the GraphQL endpoint, so that you can retrieve it faster for certain, for example, reference data and so on. You have the ability to do pagination, to do filtering and sorting, and to get those filtering and sorting constructs applied to your backend, to your database interactions, for example. You can create a fully kind of authenticated, authorized GraphQL services where, for example, you can take the identity coming from your hosting technology. For example, think about ASP.NET Core, which has a rich framework for authenticating a user and basically attaching to this identity concept a number of claims, and then you can use that identity as part of your GraphQL queries to interact with your backend systems like Azure SQL Database, and basically benefit from native capabilities like row-level security, for example, and make sure that whoever is your consumer can only access to data in your SQLDB tables or to rows in that SQLDB table that he can effectively access to, right? So these are all concepts that are part of the GraphQL specification. How to implement one of those services? Well, as you can basically code everything from the ground up, but there are a number of great frameworks available out there for pretty much every single programming language or hosting technology you can think of. Some of the most popular ones for Node.js, for example, Apollo, both server and client libraries and frameworks here are probably the most famous one. GraphQL has been created originally for Node.js services and consumers, right? So it's probably one of the most advanced ones. In the .NET space, there are typically two main options here. One is GraphQL.NET, which is probably the oldest GraphQL library. And there's one called Hot Chocolate, which is probably the most active ones in implementing new GraphQL capabilities and constructs. So this is the one that I'm going to use later on as part of my demos. Okay, so those, in Python we have Graphene, for example, but there are many more. As you have seen in the GraphQL.org website, you can find all the libraries that are available, and you can rest assured that whatever is your programming language, there is something there for you. So let's start trying to implement a very simple GraphQL service to see how it is. Right, so I'm just describing. So first of all, from a database perspective, I'm using the well-known wide word importers database here in Azure SQL DB. And for simplicity, I'm just restricting the number of entities I'm going to play with here. So we will see the classic kind of sales.customers table, the orders table, and the orders lines table, right? So that we can see, some relationships, some foreign key, primary key, foreign key relationships, and we can see how our GraphQL frameworks and libraries can deal with this kind of classic type of database relationships here, right? So from a application development perspective, I'm using my WSL, so Windows subsystem for Linux, and I'm developing these simple demos here basically on a Ubuntu distro, and using all kind of OSS open source tools and frameworks like Node.js, Python, .NET Core, and I'm using as a development tool here my Visual Studio Code. So what I can do now is to start launching my Visual Studio Code from within my WSL. You may have heard about this remote development extension. I think it's actually great. I can develop on my own Windows machine, but actually targeting a fully fledged Linux environment. So I think it's actually great for making sure that you can combine both developer productivity and making sure that you can test on pretty much whatever hosting operating system or platform you need. Right. So I have a folder here where I'm just introducing this GraphQL technology with the simplest in the simplest way possible. Right. So this is a Node.js app. I'm using Apollo as a framework here. So I'm basically, after I imported a number of npm modules here, specifically GraphQL is important, and the Apollo server one are the relevant ones for this particular query. Okay, so let's so here is my the simplest GraphQL service I can think of, right? So I'm just declaring here some references to the Apollo server class and JQL. So this is the schema definition part that I was referring to. So basically, what I'm doing here, I'm declaring what are the entities that my GraphQL endpoints will deal with. So in this case, order line, as you can see here, and then I'm declaring the query type. Query type is basically how my again a GraphQL endpoint is going to expose the entities that I declared here previously, right? So in this case, I have two queries. One is basically retrieving a collection of orders here, and the second one is basically filtering a specific order, is taking a parameter here, an ID parameter, and is returning a single order. Again, here for simplicity, I'm just I'm not connecting to any backend. I just have a collection of JSON objects here, and I'm using this as a data source, but to explain the concepts here. But you could basically retrieve this collection from a database, from whatever, from another service, and so on. And then, as I said, the other important concept here is the resolvers, right? So in this case, I create just one resolver for my query. I could have the mutation and the subscription resolvers here, and I'm basically defining how to retrieve how to resolve those queries, right? So I have the two queries here. The orders query is basically just retrieving the entire collection of orders that I have stored in that particular variable over that I described before. The order query itself, this is the filtered access to. I'm just basically invoking a function here, passing a parameters, and the function get ordered by ID is doing nothing more than just finding within my data source here, whatever entity has ID equal to the parameters that I'm passing here. Right. Next step is just to create a new Apollo server instance, passing my schema and the resolvers associated to that schema, and then I'm just listening at a given endpoint here. Right. So if I'm debugging this simple app here, I can reach out to my endpoint here, and as you can see, the Apollo server is providing me this nice graphical interface for interacting with my my GraphQL endpoint, right? So I have a query panel here and the results panel, and I have my self-documenting metadata for my for my queries, right? So you can see I have my two queries here, so I can start writing my query here. So I have to use the query keyword, and then I'm going, for example, to hit my orders, right? And for my orders entity, I want to know the ID and the customers and the customer associated, right? So then I'm executing this, and I can see, and I can already see that I'm retrieving my collection of orders here, where I have order 1, customer A, order 2, customer B, right? But here, what we can do is to start, for example, adding more information. So I can, within a single query, I can also get, what are the order lines. So ID and products here, right? So as you can see, I have my entire list. So same endpoint, I'm just declaring, asking for different data here, and I'm getting back this structured collection within a single round trip, right? And we also saw, we have a filtered option for this query, and we can say, hey, just give me order number 1, right? I don't want the order number 2, right? And another important concept here, I also have the concept of variables, query variables. So in this case, queries don't need to be static here. So I can create my own, let's say my ID here, and I can declare my ID variable here, and I just need to specify what type is this variable, and then I can pass this as a variable here, right? So as a client application, I can create a set of templates, or query templates, where I'm going to describe what is the shape of the data I'm getting back, and then I'm passing a variable where I'm essentially asking for, let's change this to 2 just to get a different response here. And here we are, right? We have the second order here with its own order line. So you can already see how I can start writing up my client apps by defining my query templates in their shape or form, depending on what customers are or what my application logic is requesting. Defining my query variables, and then just hit my backend and start working with it, right? So this is kind of cool and simple, right? So let's move to a slightly more complex app here, because what I want to do here is start integrating with my Azure SQL Database backend, right? So in my database backend, what I have to do is start implementing my own resolvers. And those resolvers can use, for example, well-known application design patterns like repository, where within my repositories for my database entities, I can write my own SQL queries, interact with storage procedures or whatever, and then I'm retrieving result sets, and I have to transform back those result sets to JSON. Or in Azure SQL Database case, I can use the for JSON clause at the back of my SQL queries and already retrieve in JSON formats my data points, so that those are immediately available for passing data back to my consumers, right? So I can further simplify the way I'm writing up my resolvers. Or I can use one of the ORM frameworks and technologies we have available to simplify the way I'm implementing these resolvers, right? So I have to write essentially less code, and be able to let those ORMs to deal with their data models, entity relationships, and query generations for me. So I don't need to write down my queries. Rest assured that all the best practices we know in terms of designing data access layers still apply here, right? So we need to make sure that those queries are optimized, are accessing the right access patterns, we have the right indexes supporting those queries, and we need to, of course, avoid the kind of unnecessary reads, like, of course, we need to ban the select star type of approach here. And if we are using an ORM, make sure that we are switching entity tracking off, because the way we are consuming our result sets here is basically in a completely disconnected fashion. So it doesn't make any sense to keep entity tracking on and read all the additional metadata that we will never need here in this particular type of scenarios, right? We need to make sure to enforce parameterized queries wherever it's possible, or to use storage procedures. We know that some of these ORM tools are also supporting storage procedures in the way they are interacting with the backend. So this is still a best practice, which is trading off between a little bit more code in implementing our resolvers, but having a much more efficient way to deal with our database backend. Right? Wherever is possible, we still have to privilege kind of batching when interacting with Azure SQL DB for example, multi-row inserts, as I was mentioning before. Right? So if I'm accepting a number of entities from the client, making sure that we are not doing a row by row type of insert in our own resolver, but we are, for example, packaging those, entities into for example, a table value parameter, and do a single interaction with the database. making sure that we have the right kind of connection pooling technology in place, and so on, right? So those are nothing new, but as application developers, we need to make sure that we are treating our backend instances, backend database instances well in the most efficient way possible, and they will give us all the performance and efficiency we need. So let's move to a slightly more complex example here, which is now dealing with my database backend, right? So there's a little bit of increased in complexity here. I'm still in Node.js, and I'm still using, if I look at my main file here, I'm still looking my Apollo, using my Apollo server framework here. But now I'm also using, from a database perspective, I'm using my SQLize. SQLize is a famous package in the Node.js space, which is basically providing ORM capabilities. And in this particular case, I'm using my SQLize against my Azure SQL Database instance here, as you can see, right? So I just, I'm declaring a new instance here of SQLize with my database connection string attributes, and I'm just telling SQLize to use the Microsoft SQL Server dialect, right? And SQLize behind the scene is using the tedious database driver to connect with my SQL Server backend here, right? And I'm just declaring my connection pool strategy here, and so on. And then I'm basically importing my database model, and my database model is declared here again by leveraging leveraging SQLize for taking my database table. In this particular case, I'm using orders, which belongs to the sales schema, and I'm defining a object within Node.js that has these three properties here, right? So order ID, customer ID, and order date. Nothing particularly fancy here, but I can also describe the relationship. For example, in this case, I can associate my order class with my order line class and telling SQLize that, hey, by the way, my order entity has many order lines, right? And I'm also describing where the foreign keys and how I want to get those lines basically injected into my order entity. Same way, I'm in the order line class, I'm just basically declaring my attributes here, and I'm saying, hey, by the way, order line is associated to my order, right? So all these order lines will belongs to my order line, and the foreign key that I'm using is no surprise, order ID. Okay, so here is where I can tell SQLize exactly what type of data mapping I'm using, all the other database constraints like primary key and so on. And SQLize will basically give me whatever I need in order to interact with my database backend. Right? Actually, SQLize is also providing concepts like migrations. So I can create my database schema from the ground up as code here. And then I have a CLI tool like what we have in Entity Framework for .NET that can create all these database entities for me, adopting, using a migration approach, right? So as you can see here, migrations are very similar to what we have in Entity Framework, where basically taking the code model that I have here are going to generate my tables within the database. This can be good for those web apps or function apps where I'm not starting from an existing database as I'm doing with the wide world example here, but you can start with the code first approach essentially, right? Then what I'm doing in the schema here, similar to what I showed previously, right? So I'm describing my schema, and I'm describing my, the queries and mutations that I have available for this particular GraphQL endpoint, right? And, after the schema, I need to implement the resolvers. And you will see here, resolvers are largely simplified by the usage of an ORM like sequelize, right? So here are all my queries, orders, order lines, all orders, and my mutation where I'm actually creating a new order line. And what I'm doing here, I'm just referring to my sequelize model, which is injected into this function. And I'm just using some of the getter methods that sequelize is offering me. So no SQL, no T-SQL at all. And for example, in this case, when I'm filtering my order, I'm just finding a new order where order ID equals my my parameter. And I'm including my order lines, because this is, as you remember, an association that I declared in my model as a property called line within my response, my query response, right? Same for all the other tools here, right? So let's try to execute and debug this particular one. And let me look at my debug console. Oh, we have an error here. And for whatever reason, because port for, yeah, I still have an existing instance up and running. So I may want to close this and to reopen. Okay, let me see if we are more lucky now. Oh, for whatever reason, port 400 is probably stuck somewhere. So let's move forward, because the next piece that I was going to show you is once you have this, it's very, very simple to just take the exact same code and to, for example, move it into a Azure function. And that's one of the many hosting technologies that we have available right within, for example, Azure or any other cloud platform. You know, we can host our function as a serverless function within Azure, and for example, coupled with Azure SQL Database in the serverless mode, you can create a completely serverless backend for your particular query. And again, you will see, you know, there's nothing really changed, with the exception of using a flavor of the Apollo server, which has already all the handling capabilities for Azure function here, but that the code is exactly the same. I'm just passing to my Azure functions the control, instead of having a local server running here at my local machine. And what I'm doing here, I'm just maintaining the exact same stuff here through my Visual Studio Code Azure Function extension here. What I did was just create a new project and publish my function in Azure Function, right? So the function is untouched, and I'm now running, as you can see here, the same exact function that was running on my application. I'm running it instead in my public address here. So this is the function that I just created, and here are some of the queries that we were looking for, right? So in this case, for example, query can have a name. So I call this particular query order by ID, and what I'm doing here, I'm just filtering my order by ID here. So this is the first time my function is running, so it's probably spinning up, you know, behind the scenes my compute capabilities and such. So it's probably going to take a few seconds as a first starter. Let's see, or maybe it's better to just refresh the entire site here and hope that demo gods will assist. Okay, here we are, right? So as you can see, I have my, oops, I Now it should be faster. Here we are, right? So now I've created for this particular order ID. I can query my order line, same stuff. But I can also do some more complex queries here. Like for, in this case, I can query orders and order lines for this particular order ID, right? Or I can start doing some more interesting stuff, like, for example, creating aggregations, right? So I want to query all the order lines belonging to order ID 13, and I want to have a count of them, right? So let's say in this case aggregations. Okay, you can see we can aggregate and have a count of how many order lines we have. So if we go back to our code here and just take a look at how I did this in my resolver, I just created yet another flavor here where I'm calling the find and count all instead of just the find, right? So what I'm doing here, I'm returning the count property of my result set, which is basically a select count of all the rows, all the filtered rows that I'm returning here, and again, I'm just getting back, of course, my collection of rows, right? So this is basically what I'm doing here, and you can see same stuff for example, my mutation, where I'm basically invoking this create order line mutation, and I'm calling my model and just creating a new entity with all the data points that I was getting back from the client, right? So this is basically how you're implementing GraphQL services, interacting with your database and going through Azure Function. Oh, I forgot. Let's open up another one just for the sake of looking at, for example, full .NET implementation. As I was saying, I'm using hot chocolate, but essentially the concepts are exactly the same, right? So what I'm doing here, this is an ASP.NET app hosting my my GraphQL service, is essentially similar to what you would have without any other web API solution sitting in ASP.NET. So you will have this. You will have, of course, in this case, I'm using a entity framework context. So I'm just passing through dependency injection my wide word importer context here. We'll get that in a minute. I have my connection string, and then I'm just adding my GraphQL service to the list of available services here, and I'm just passing the query types that I have available. So the query type are basically described here. So you can see that here I have the same approach that I was having in Node.js, right? So I'm describing what type of queries my resolver is exposing, right? In this case, I have a get orders or get single order, and my query type is basically reflecting. So this is essentially my repository where I'm again exposing whatever entity my database context is providing me, right? And here I have my WWI context, which is again a simple entity framework core backend, entity framework core context where I have my three DB sets: orders, order line, and customers, and nothing more. Just few metadata description here. And what I can do here, let's see if this time ports are okay. Here we are. So you can see same playground that we were looking in Node.js is available also here. So what I'm doing here, I'm trying to, for example, retrieve my order and customer for my order ID 2. And let's take a quick look here at the debug console, because I turned on logging for my entity framework anti-framework context here. And then you can see the SQL query that has been generated here. So as we can expect, I'm selecting from my orders table, joining with my customer table on customer ID equals customer ID, and then I'm filtering with parameterized query here, and I'm returning back my result set to my GraphQL to my GraphQL resolver here, right? So same as I would do my orders and lines here. So you can see that the queries that I'm generating in the backend. Let's expand this a little bit. Okay, the query that I'm generating here in the backend is again joining this time my orders, my customers, and my order lines, and I'm again filtering by order ID here and ordering my result set so that from a GraphQL perspective, I can retrieve back this JSON fragment. Right? So this is the kind of database interaction without basically writing any T-SQL code that you can have, so that in GraphQL clients can effectively define the shape and the size of the data that they want to retrieve. Of course, you as a developer can limit. For example, you can define what are the maximum limits in terms of retrieved entities and stuff like that, right? So you can effectively control, but the client is in command in this case in the way he's basically retrieving data. So from a client perspective, what can I do here? So what clients have to do to consume a GraphQL? So basically they have to describe their data requirements through defining GraphQL queries, as we were seeing, and then display the results in the UI. Nothing more, nothing less. So there are existing frameworks available for pretty much whatever client front-end tool set and framework there are for React Native, Angular, Xamarin, Forms, and more, in order to simplify the way you are describing your data requirements, getting data back in a strongly typed fashion from your service, and just show the data into clients. But just remember, at the end of the day, a GraphQL client is an HTTP client capable of doing a post, right? This is effectively what it's doing. So if we go back to our projects here, I have a very simple GraphQL client here, which is doing exactly what I just described. I'm not good in designing UIs, so I'm just stitched to a piece of console client here. But what I'm doing here, I'm defining my endpoint, and I'm using that function that I just published as an endpoint. I'm defining what is my request, right? So this is the query that I'm executing. I'm using a variable here just to show you that this is static, basically static code, but I can pass a variable that may come from a text box or from whatever, right? And then I'm sending my request in a sync fashion to my backend service, right? And I have a typed response, which is this orders and line type of response here. And then I can play with whatever is coming back. In this case, I'm just deserializing the full kind of raw response, the JSON response, or I can access to my type, order type and order line, whatever. And if I go ahead and let's open up my terminal here and do a .NET run, just for the sake of simplicity, we should see, here we are. So this is the raw response that I'm getting back. So my data element here, my order element number 12, order data, or customer ID, these are properties of my orders tables. And then the order lines, right, fully joined. I also get back in a structured way if there are errors or exceptions that have been generated on the database side or on the server side. This is the way you can track and you can interact with exceptions from a client standpoint. Or you may attach extensions and do some basically post-processing of the results and getting back those post-processing results as well. And here we are also, in a typed fashion. So this is my, order ID and order date coming from those typed objects, right? So here is how client applications can deal with it. And again, what I'm using here is the GraphQL.net client app, a NuGet package that you can just include as part of your client applications. But as I said, there are embedded clients for pretty much every UI, every front end kind of framework applications like React and Thread. For those of you that are front end developers, you should be definitely familiar with that. And this is how to consume it. So in summary, because we are getting on slightly, off time here. So GraphQL is a great, framework and tool for designing your data services interactions from your application perspective. It's great for integrating existing data services, data sources like databases or existing APIs, REST APIs, and such. And the goal is effectively to reduce round trips from applications, but also round trips from within your application tier and the database. And you can work with all the familiar client drivers and frameworks and ORM packages and so on any programming language. We are seeing Node.js and .NET Core here, but same for Python and same for everything else, right? So if you think about that, with few lines of codes, you can deploy your GraphQL solution on Azure Functions and Azure SQL Database in a completely serverless fashion, and literally with few bucks, or actually from within the Azure free accounts that are actually available, where you have around $100 plus of free Azure usage. You can deploy your GraphQL services with Azure Function Serverless and with SQL Database Serverless instances, and have a fully serverless platform consuming your data services up and running. Okay, so thanks a lot for your time. We'll go through the questions that may be open, but before that, I wanted to thank our knowledge partners here for giving organizers the ability to set up this fantastic event. And thanks again for your time. Let's see if we have questions here. Okay, so what versioning rules like REST API not needed for GraphQL? So for GraphQL, you have a single endpoint effectively, right? So a single endpoint is in order to deal with multiple versions of your particular API, you have to create yet another URI, right? V2, V3, V4. This is a typical approach that versioning REST APIs you have. With GraphQL, what you can do is just, for example, start deprecating some of the entities that you don't need anymore, or the fields that you don't need anymore, right? By, for example, sending back a clear message to your consumers saying, yeah, you have this field available here, but listen, this is going to be deprecated. And you don't break anything on the client side. So the client side will still connect to that GraphQL endpoint, and queries will continue to work. Right, so it's very different in terms of versioning approach. It's not, of course, solving all the problems, but it's dramatically simplifying the way you are dealing with versioning. What is OData? OData is a JSON and REST-based representation protocol for data entities that Microsoft introduced around more than 15 years ago. It's been used on a number of technologies. For example, Power BI, just to give you one, is still using that. A number of backend services are using that. Excel is using OData for consuming data feeds, for example. Other third-party companies like SAP is using that in SAP BW, and it's pretty decently present in the market and will continue to be there because it solves some very specific data representation problems over HTTP. But GraphQL is slightly different. So, to answer the last question, GraphQL is not a Microsoft product. GraphQL as a set of specifications has been defined by Facebook, and now there's a foundation which is effectively dealing with the evolution and the future of GraphQL, which is composed by a number of third-party companies, and so GraphQL is fully open source now, and Microsoft is not involved, but there are a lot of existing frameworks like the GraphQL.net and the Hot Chocolate that are implementations within the Microsoft stack of GraphQL of the GraphQL specs, right? So you can definitely use that. Okay. So if I'm not mistaken, there are no more Q&A questions here, but feel free to ask more, and I would be happy to provide answers.
One question just popped up in.
Oh, let's.
Can we combine multiple APIs?
Yeah. So this is one of the purposes of GraphQL actually. So in your resolver, what you can do is you can use a GraphQL client or simply GraphQL or an HTTP post, as I said, to query your additional APIs, right? And to combine as a result of those multiple queries, to combine into a single response to the consumer, which is one of the ways you can actually simplify. This is, by the way, this is what Facebook did with their client apps. So the problem of the initial Facebook mobile app was that the client was calling actually 20 different REST APIs in order to create the initial page of your own Facebook app on your mobile, right? And this means 20 different round trips, consuming a lot of bandwidth, consuming a lot of battery, and so on. What they did with GraphQL was to have a single interaction between the client app and the backend, and by basically combining those multiple REST APIs into a single call. So from the GraphQL endpoint to the backend APIs, yes, there were still multiple API calls, which has been kind of optimized moving forward, but you can still maintain your original APIs and combine those multiple APIs into one. This is one of the goals of GraphQL for designing your application endpoints.
Perfect. Looks like the Q&A panel is all clean.
Yeah. Great.
Great. Perfect timing. It's just about to be 3:15 India time.
Perfect.
Yes.
Okay. So should I stop sharing now?
Yes, of course, if you wish to.
Perfect. Okay. Yeah, I think I'm done.
Right, Silvano. So thank you very much. This was Silvano Coriani for us from Microsoft. And I think, Silvano, thank you so much. There was so many new things to learn. I mean, you have shown things that I have never seen before. So all those new techniques and the new innovations, I'm sure the community will appreciate. Friends, as usual, please give feedback for this session. The links are there in the chat window. Let us know how well have you enjoyed and the new stuff that you have learned. Thank you very much.
And I'm glad to be able to bring the developer angle to this great SQL conference.
Absolutely. This was much needed. So thank you so much.
Thanks.